This is Jabcan. This is Jabcan. This is Jabcan. I hope these aren't gang signs. Today we're going to do elimination reactions in 27 questions. Elimination. Elimination. Imagination. That's what I was thinking of. Imagination. Imagination. If you know, you know. And if you don't, then it's probably for the best. It's not exactly a show that has the best influence. Question number 1. Name 2 ways a carbocation can reach stability. Number 1, by bonding to a nucleophile in an SN1 reaction. Number 2, by losing a proton to a base in an elimination reaction to form an alkene. Question number 2, what is the first step of an E1 reaction? The first step of an E1 reaction is the cleavage of the alkylhalide into a carbocation and a halide ion. I'm going to use this as an example, but the same principles apply to other reactions. Question number 3, how many transition states does an E1 reaction have? An E1 reaction has 2 transition states. Question number 4. What is the first transition state in an E1 reaction? This right here is the first transition state of an E1 reaction. In it, you can see the bond between the carbon atom and the halogen breaking. It's breaking. Question number 5. Do E1 reactions have intermediate? Yes. Question number 6. What is the intermediate in an E1 reaction? The intermediate of an E1 reaction is the carbocation formed in the first step. Question number 7. What is the second step of an E1 reaction? In the second and final step of an E1 reaction, what happens is that the base removes a proton from the carbon atom adjacent to the carbon that's positively charged. In doing so, the sigma electrons in that CH bond become attracted and shift towards the positively charged carbon, forming an alkene. Question number 8. What is the second transition state in an E1 reaction? This right here is the second transition state in an E1 reaction. Question number 9. What order of kinetics do E1 reactions follow? E1 reactions follow first order kinetics. Question number 10. Are E1 reactions competing reactions? Explain your answer. Yes. 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 The reason why E1 reactions are competing reactions is because the first step of both of these pathways of reaction is the cleavage of an alkylhalide into a carbocation and a halide ion. So they both form carbocations. Carbocation formed can go on to react through the E1 pathway to form an eliminated product, or it can go on to react on the SN1 pathway to form a substituted product. These two are competing. Those are competing reactions because both of these reactions are possible. Blah, you get the drift. Question number 11. When are E2 reactions most likely to happen? E2 reactions are most likely to happen when an alkylhalide is reacted with a strong base. Question number 12. How many steps does an E2 reaction have? E2 reactions happen in one step, but there are loads of things that happen in this one step. It's what we call a concerted reaction. Question number 13. What are the 3 things that happen in that one step? Number 1, the base is forming a bond with hydrogen. Number 2, the carbon-halogen bond is being broken. And number 3, the halogen is departing with the electrons from that carbon-halogen bond. So all these 3 things are happening in that one concerted step. Question number 14. What is the transition state of an E2 reaction? This right here is the transition state of an E2 reaction, and in it you can see what I just described. Those 3 things happening in that transition state. Quite the menage a trois, huh? Question number 15. What order of kinetics do E2 reactions follow? E2 reactions follow second order kinetics, and it's because there are 2 particles in the transition state of its rate determining step. There's the alkylhalide and there's the base. Question number 16. Question number 16. What are E1 and E2 reactions often referred to as? Referred as? Don't know. I don't know. Beta eliminations. Beta. Beta baby! Baby baby! Question number 17. Why? Both E1 and E2 reactions rely on the removal of a beta hydrogen to form their products. Question number 18. What are alpha and beta hydrogens? Let's take a look at this alkyl halide right here. All the hydrogens attached to the carbon holding the halogen are known as alpha hydrogens. All the hydrogens attached to carbon atoms adjacent to that carbon atom holding the halogen are known as beta hydrogens. Both E1 and E2 reactions involve the removal of a beta hydrogen to form an alkene. Question number 19. How can beta elimination affect the products of elimination? I'm sure there was a better way to word that. There can be different alkyl groups attached to the carbon holding the halogen in an alkyl halide. If there are different alkyl groups attached to that carbon, there are different types of beta hydrogens that can be extracted. The removal of a beta hydrogen from different alkyl groups adjacent to that carbon holding the halogen can result in the formation of different types of alkenes. Because of that, when some alkyl halides are reacting through elimination, they can form different alkenes, different products. If we use this alkyl halide as an example, we can see that extracting a beta hydrogen from this alkyl group will yield this alkene. Extracting a beta hydrogen from the other alkyl group will yield that alkene. That's two different products that are very much both possible when this alkyl halide and others like its kind react in elimination reactions. Question number 20. What is Say-Steph's rule? Say-Steph's rule states that in an elimination reaction, the alkene in which the doubly bonded carbon atoms are attached to the most alkyl groups will predominate in the product mixture. Another way of saying that is that the most highly substituted alkene will predominate in that product mixture. Question 21. How does this relate to alkene stability? A more highly substituted alkene is more stable than a less substituted alkene. 22. Based on this information, how can we predict which alkene is formed in an elimination reaction? In an elimination reaction, we can predict that the elimination leading towards the most highly substituted alkene will predominate. That most highly substituted alkene is more stable, which means that the reaction leading towards that product will have a lower energy transition state. And when it comes to reactions, the lower energy transition state is always the goal. You know, the reaction is lazy. It doesn't want to spend unnecessary energy that it doesn't have to. So it's always going to go and opt for that reaction pathway that involves a transition state that has a lower energy and is more stable. So if we use this as an example, and we look at the products or the possible alkenes that can be formed from this reaction, we can then predict that that alkene, which is the most highly substituted alkene, will predominate as a reaction and in the product. And that's because why? It's more stable than the less substituted alkene and the less substituted product. 23. What else can influence the structure of the end product? Isomerism of the end product. 24. Why is this? Explain using an example. Trans isomers predominate in elimination reaction products. In trans isomers, there is less steric hindrance than in the cis isomer of that same alkene. Trans isomers have less steric hindrance and are therefore of lower energy than cis isomers of the same alkene. If we look at this example here, we can see that the trans isomer has the two heaviest groups attached to the carbon atoms on opposite sides, whereas the cis isomer of the same alkene has those two groups on the same side. Now, it is obviously more favorable for them to be on opposite sides because it's less steric hindrance, and because of that, the transition state of the trans isomer of this alkene will be of lower energy than the transition state of the cis isomer of the same alkene. And that's the reason why trans isomers predominate or tend to predominate in elimination reaction mixtures or product mixtures. 25. What are Hoffmann products? Sometimes you may find that the Say-Steph rule does not apply, and you may find that the less stable, less substituted alkene is in fact formed. That is what we call a Hoffmann product. Question number 26. Why are Hoffmann products formed? Hoffmann products are formed if the transition state leading to the more higher substituted alkene has too much steric hindrance in it. The steric hindrance in the transition state of that highly substituted alkene would cause the transition state to in fact be of higher energy and would defeat the purpose of choosing to opt for that highly substituted alkene, and it would just go instead opt for the less substituted alkene because there wouldn't be as much steric hindrance in it as the more substituted alkene, and therefore would be energetically more favorable than going for that highly substituted alkene. 27. What three things can cause steric hindrance? Number 1, the size of the attacking base. The bulkiness of the leaving group. The bulkiness of the group surrounding the leaving group. That can also cause steric hindrance. In these reactions, there is a balance. It's always going to try to opt for the reaction pathway of lower energy that has the lowest energy transition state. Because let's face it, these reactions is just lazy. They ain't trying to do no work. We all ain't trying to do no work that we don't have to. We don't want to do that. So it's always going to bear in mind what would increase the required energy for the reaction and what would decrease it. So when you're looking at these reactions, always bear in mind that the pathway that may seem to lead to the most stable product and the lowest energy transition state may also sometimes not. Have you watched Pan's Labyrinth? Do you remember that guy? Pan's Labyrinth was scary, mate. But we're done, and that's it. That was elimination reactions, and it's finished. Thank you.